Okay, connecting back to what we just saw happen on those first three examples where when we evaluated our derivative at the particular point that was given to, we either got 0 or we got undefined. At the top you have the definition of what's called a critical number, and critical numbers is something we're going to talk about throughout the next few sections. It says at relative extrema, the derivative is either 0 or does not exist. So where you have extrema, maxes and mins, your derivative is either going to be 0 or does not exist. These x values are referred to as the critical numbers. Okay, so going back to the idea of closed intervals that we talked about earlier, this is going to be your steps that you're going to go through in order to locate your extremum. So step 1 is to find the critical numbers of the function in the open interval from A to B, which means you're not going to worry about the endpoints. You're only going to worry about what happens in between to begin with, okay? So find your critical numbers. Now remember, critical numbers, the definition right above this, that's where your derivative is equal to 0 or your derivative does not exist. Step 2 is to evaluate the function at each critical number. Step 3, evaluate the function at each endpoint of the closed interval. So this is where we'll pick back up with the endpoints. And then on step 4, the least of these values is the minimum and the greatest of these values is going to be the maximum. Of course, the values, it means when you evaluate the function at the critical numbers and then you evaluate the function at the endpoints, then after you've evaluated and you have all these values to compare, the smallest will be the min and the greatest will be the max. Okay, so here's our first one. Okay, so our function is 3x to the 4th minus 4x cubed, and the closed interval that we're going to deal with is from -1 to 2. Okay, so it's stated that first of all, you've got to find the critical numbers. Okay, going back to the definition of critical numbers is where your derivative is equal to 0 or does not exist. So you've got to find your derivative. That would have to be your first step. So just using your power rule for each of these terms. Okay. Now, critical numbers, again, where is your derivative equal to 0 or where does it not exist? My derivative is just a polynomial function, so your polynomials are not ever going to be undefined or to have places that do not exist. All that you got to find on a polynomial is where is it going to be equal to 0. Okay, so you just simply set it equal to 0. You do have a common factor of 12x squared that you'll want to factor out, which will leave you with x minus 1. Okay, so you have 12x squared equals 0, so that's going to end up giving you x equals 0. And then x minus 1 equals 0 is going to give you x equal positive 1. Okay, so that's going to be your critical numbers in the open interval. Okay, so that would be like step 1 out of those 4 steps that you wrote down a few minutes ago. All right, step 2 says to evaluate the function at each critical number. Okay, so you're not going to substitute these values back into your derivative. You substitute them back into your function because you're wanting to know how high or low is this point located on this function. Okay, so we're going to first evaluate at 0. So of course that's just going to end up giving us 0. Then evaluate it at the 1. And this is going to end up giving us -1. Okay, so there's step 2 out of your list. Step 3 says to evaluate the function at each endpoint. So this is where your closed interval is going to come in, where it goes from -1 to 2. So now you evaluate your function at each of these values. And that will give me a value of 7. And now my other endpoint is at 2. And that will give me a value of 16. Okay, so step 4, the least of these values is your minimum. So out of your values, so these represent Y values. I mean, these are actual locations on your graph. Like this would be the point 0, 0, 1, -1, -1, 2, 16. So out of these points, what's going to be the highest point, what's going to be the lowest point? So it'll have to be the Y value that determines how high something is or how low something is. So that's why you determine your answer from these 4. So this would be your smallest value. So this is going to represent your minimum. And this is your maximum or your largest value out of the 4. So this is going to represent or be your maximum. Now, one other thing I want to point out to you, of course, we didn't have to worry about it on this problem, but since you're given a closed interval here, the values that you get here would need to lie within this interval, or you actually don't bother evaluating it here. They throw in a few problems every once in a while that's that way. Like for instance, if I had gotten x = 5, I would not bother testing or evaluating 5 down here because it's not on the interval that I'm concerned about anyway.